So I have quizzes graded, but they're not in the grade book yet. So I'm going to give each and every one of you the opportunity, if you wanted to. It doesn't matter if you requested more time or not. If you wanted to, you can come in. I will be on campus all of today, all the way through 8th period. Okay? So if that fits your lifestyle, that's great. Tomorrow, I will be in my office or in my other classes. So this includes you can come to my other class and I'll have the material with me. Through 6th period. Okay? Does that make sense? So, Sam, you just did yours. You got 44 out of 46. That's awesome. But other grades, this is out of 46. I got an 8, so far an 18, a 28.5, a 9, a 22, an 8.5, a 32, a 28.5, a 22, a 43. Brian, good job. A 43 out of 46. A 4, 30.4, 39, 45, 10, 32, 46, 19.5, a 1. Name was right. And a 35.5. So, huh? The name was right. Out of 46. So, if, though you don't know what your score is, your score was probably read out loud. Sage, you did really well. 45 out of 46. Good job.
How old did I?
Wait, did I take that?
No, we took it yesterday. You were in college. So, if you would like more time, if you'd like to come in and make corrections, I just told you when, right? Make sense? If I would like to get these back to you all Monday, that way I can go over them. So, if you have an off period and I'm teaching, come to one of my rooms. I'll have it with me. If you are off first or before school or 4th or 6th, for the most part, you can be in my office. 7th and 8th, I'll be in my office today as well. And then tomorrow up through 6th.
What about 3rd period? Are you off?
I have a class, so just come downstairs.
Wait.
My schedule's on my door in my office, so I'm just downstairs. Cool? And you're welcome to come in there and
Are the kids going to bring money in?
our kids bringing you money in.
Oh, yeah, I think that's only certain period.
Usually they don't pay me off.
Mine is next period.
Next
Where
period.
a
Oh,
teacher
third
counts?
period, right? Yeah, the penny song. Yeah. So
When a teacher counts all the periods.
that's it. Yeah.
You could pretty much get
What's
like,
that?
a whole
Oh,
day
so
off.
then it's not a good idea?
The hard thing is those guys think, oh, I'm going to stall. Well, that's being videoed, so yeah, you can stall me, but go watch the video. So that's our. Doesn't matter to me. So. Yes.
Can I know what I taught on my test?
Yeah. When you come in, when I get it to you, I'll show you. Cool.
Mr. Strauss?
Yeah.
Okay, if I'm in 3rd, will I be too distracted to take the test?
I can put you in the office next door too. So.
I don't do well with distractions.
All right. Next thing on the agenda has something to do with math. Obviously, we are in the midst of raising money this week. Yes, for pretty good, darn good cause. And but I just wanted to invite all of you. The talent show is tonight. My band is playing.
Oh boy.
Okay, we're anyone know? $5. I think it's 5. I always give them 20 when I walk in. They're like, here's change. I'm like, no, it goes to a good cause. They're like, you're one of the performers, you don't have to pay away. Whatever. So, my band is playing. We have 2 songs we're doing.
What's
So,
your band called?
Bruins Brothers.
Who's all in?
Yeah.
Myself, Mr. Mimak, who's a math teacher. He plays saxophone. Mr. Burnt, who's a math teacher. He plays bass. Mr. Libby plays trumpet. He is the orchestra teacher. Mr. Matuszek is a math teacher and a guitar player and a person. has retired from here. He used to be one of our tech people named Mike Osterpinski, and so he's on drums.
I have a question.
What do you go ahead?
What do you play?
I sing.
You sing?
I think you would be kind of like, whoa, are you kidding?
That may be kind of worth to see. I
So,
was just gonna ask
When
you,
is
is
the
it
talent
worth
show?
my money to come see?
well, yeah, I mean, we're not the only act. We are
Yeah.
the second act. I think it might be. I
Like
think it.
Daniel Gano's last
So, and if you miss tonight for the talent show, we will be performing in the assembly. So we'll be doing Sweet Home Chicago as you guys come in, and then once it's all up and going, we will go into Sweet Caroline, which will be a lot of fun.
Oh yeah.
Wait, is there like a talent show for like school so we don't
Yeah.
have to come here?
What time is it at?
Tonight starts at 6:30. So
It starts at what?
6:30 is the talent show tonight. Tomorrow is 8th period, so every class period is short. So if
Oh boy.
if you are in the midst and you're like, hey, you know what? If you want to see what the Bruins brothers, if you go onto YouTube and you type in Bruins brothers and then stirrup, you'll see what we looked like 2 years ago.
Can I do it right now?
Do it, but we're going to start teaching you. So if you want to do it.
Make sure you don't suck.
What's up?
I got practice tomorrow.
Do you? I'll be in the assembly tomorrow, though.
Yeah.
You there?
YMCA?
I'll find you in the audience. I love coming out and see something.
It only comes up with your math video now. It doesn't come up with anything else.
Bruins brothers didn't show up?
Blues Brothers? YMCA? Yeah, I got this name. It just shows me nothing.
I got Wait the Bruins Brothers.
Wait, that's it.
You got what?
Got it.
Got it.
Look, if I come in, probably like 6 p.m.
So in front of us. So it's called the zero product property. This goes along with what we're doing here. So if we just took a look up here and said, okay, we have x times y equals 0, where x and y are variables. If x times y equals 0, what can you guarantee about either x or y if we're multiplying? One of them's got to be 0, right? So you could just go and plug things in. So this is what we're going to start aiming towards with this class. So let me bring this out. So the zero product property, if a times b is equal to 0, then either a is equal to 0 or b is equal to 0 or both are equal to 0. Okay? So if we're multiplying two things together, if one of the things is 0, it will make the whole thing 0, right? It's like the joke, if you were to multiply all the if you were to take all of the hair that people have on their heads and multiply it all together, what number would you guarantee to get? 0, because there's some people who have 0 hair, right? Of course, you get some kids who are, oh, wait a minute, so we have about 256,000 follicles. It's like, yeah, some has 0. Doesn't matter. All right, are we good so far?
No.
Ready?
Yep.
Everyone else? Sorry, all right, so take a look at this one. If we were going to use the zero product property, and we had 5 quantity, x minus 3, and we're multiplying 5 and x minus 3 together, in order for this to be 0, in order mathematically for this to be 0, what number needs to go in for x? Yeah. Positive 3. Yeah, so if I plug a 3 in there, I'll get 3 minus 3, which is 0. 0 times 5 is 0. Does that seem okay so far? Yeah. All right. Problem number 2, there's actually 2 different numbers I can plug in because I have 2 different places x exists. So what number can I plug in there that will make the whole thing 0? 0, because 0 times that quantity is 0. What number should I plug in right there to make this part 0? Almost. Negative 5. So then there's 2 solutions. Okay, and a solution is something that makes it 0. The third one, we have an x, we have x plus 1, and we have x minus 4. So if I just have x standing alone, if I wanted to make the whole thing equal to 0, what does this x have to be? 0. What does this x have to be? Negative 1. What does this x have to be? Positive 4. So if I plugged in 0, negative 1, or 4 to any of those, the whole problem is going to become 0. Yeah. Well, it's a variable, so it can be represent any number. So in this case, we're just trying to see, hey, we're multiplying 2 different things or 3 different things together. Just one of those has to be 0 in order for our answer to, or just one of those parts has to become 0. Some of it might be a binomial, but some of it might be just a letter. So number 4, positive 2. That's the only thing that's going to make the whole thing 0, right? And then we get like a little different. And it's like, ooh, that becomes a little trickier to look at. Do you agree? The others kind of stuck right out. So what I'm going to do is I'm going to take 4x minus 3, and I'm going to go equals 0. So if I add 3 to both sides, I get this. Agree? And then it asks 4 times x, so I'm going to divide each side by 4. So I get x equals 3 over 4. So if I plug 3 over 4 in right there, this part becomes 0, so 0 is a quantity times another quantity has to be 0. If I wanted to figure out what this one had to be, I'm going to do the same thing. I'm going to go 2x plus 9 equals 0. Subtract 9. Divide by 2. So if I take negative 9 over 2 and plug it in right there, I get 0 for an answer. Okay? This type of math is used a lot in security, meaning they use mathematical algorithms, now probably not real simple math algorithms, in order to protect secrets of companies and banks, and it's like kind of where your password exists. And a lot of times there's an algorithm in place that will do a mathematical operation, and once the mathematical operation becomes 0, that means you're in. You found the solution. Okay? Can I move on? All right. So we recall the value of the function and its y value. The x-intercept is the 0 of the function. So remember, this is the x-intercept right here. So if you found it, it would be 1, 2, 3, 4, 5. This looks like the point 6, comma 0. Is that okay? That means if I had found the linear equation, if I had plugged 6 into the x value, my y value would result in being 0. Okay? Now, where it crosses the y-axis isn't a solution. It's a point that exists. It becomes a unique point because it does cross the y-axis. But where it crosses the x-axis is where we're trying to focus on this stuff. Okay? So kind of make that, start making that bridge, going, okay, wherever it crosses the x-axis, that means my solution, if I plug that number in, my solution will become 0 because it's going 0 in the y direction. Even if you don't have a y to look at, that's what we're doing with this. Okay, the fundamental theorem of algebra, yay, here's the big thing. There's 2 fundamental theorems. There's the fundamental theorem of algebra, and then there's the fundamental theorem of calculus. Okay? We're going to deal with, obviously, algebra. This is the easiest thing to comprehend that people just blow way out of proportion thinking it's got to be more than that. So let's see. Okay. Okay, the fundamental theorem of algebra states that for each polynomial, so as I have if I could have like x squared plus 3x plus 7, or I could have it as 2x plus 5 in parentheses and 3x minus 2 in parentheses. The fundamental theorem of algebra states that for each polynomial with complex coefficients, there are as many roots as the degree of the polynomial. Okay, so remember, we name a polynomial by its highest degree. If it's second degree, it's a quadratic. If it's first degree, it's linear. If it's third degree, it's cubic. If it's fourth degree, it's quartic. It's fifth degree, but then we just start calling it a polynomial. Yes, we could say it's quintic, but we're not worried about the Latin. So if I had something raised to the 9th power, fundamental theorem of algebra would say, hey, you have 9 solutions. Okay? That's the in and out of it. Now, here's the problem with solutions. Have you ever, on any of your worksheets, whether in this class or any previous classes, let's say you get the square root of a negative number. What do you put for an answer? A lot of people put no solution, right? And then the teacher might correct you, saying, no, there's no real solution, because the real number system is the name of the number system, that there's not a solution that exists in that to have a square root of a negative. So there are things that are solutions that we've been calling no real solutions along the way. Well, we'll get to that a little bit. Okay, so it says apply the fundamental theorem of algebra to determine how many roots a function has. So y equals 15 minus 2 to the x. X is raised to what power right now? The first. So there's a little 1 right here, which means I have one solution. Problem number 2. What's the highest exponent in number 2? 2. So how many solutions? Okay, because of that 2, that means we have 2 solutions. What is the next one? What's the highest exponent of the next one? 3. So how many solutions? 3 solutions. And again, a solution is something that if you plug a number in, your answer comes out to 0. Yeah. Okay. This fourth one, I have like terms first off. Do you agree? But they cancel. Right? That and that cancel because they're opposite sign. So what's my highest exponent now? There's a 1 right there. Right? So I have one solution. Think about this for a second. Y equals 5. It's a horizontal line at 5. Right? So if that's the case, if it's a horizontal line at 5, is it going to cross the x-axis? Does that make sense? So won't have a solution? No solution. Because technically, I could have written this x raised to the 0. X to the 0 is 1, which means this would have been 0 solutions. Okay? Jasper, did I answer your question on that? Yeah. Cool. You feeling okay? Happy day? May I move on? Yeah. So we're looking, a solution is where it crosses the x-axis, or if I plug that solution back in, it'll make my answer 0. All right? Okay, so we're applying the fundamental theorem of algebra to determine how many roots the function has. So we're just looking. Crosses the x-axis there, 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 there. How many solutions? 5. So this could have been an x to the 5th power. Okay? This has 5 solutions. Solutions. That's a solution. Sorry, I'm kind of goofing up. What about this next one? 1, 2, 3, 4. So this is an x to the 4th power. There would have been 4 solutions to this answer. Now, we're not really going to get into making these graphs at this point. It's just, it becomes easy to see, oh, look how many times it's crossing the x-axis. Wherever it crosses the x-axis, you plug that value back into the answer, the result would become 0 because you're going 0 in the y direction. Does this all seem good? Everyone seem kind of content with it? Number 8. Now it says they want us to factor completely and then use the zero product property to find the roots. The roots are where it would cross the x-axis, or if you take the roots and you plug it back into the answer, it gives you an answer resulting in 0. Okay? So I'm going to just take a look at this part right here, and I want to factor that. So we can do our traditional way. My magical number is -12. So that means I have alternating signs, right? And what factors of 12 could we possibly make 4? What was it? 6 and 2, absolutely. Which one has to be positive to add up to +4? The 6 is positive, so the other one's negative. All right, so then we're going to expand this. We get x squared plus 6x minus 2x minus 12. Factor an x out. This is what we've been doing, right? That negative comes down. Factor out a -2, so I'm factoring -2 out, so I get x. All both sides switch. So I get that. Which means I have x minus 2 and x plus 6. Okay? Now the only thing, so that's exactly what we've been working on. The only thing I'm going to change is this. Okay? So what number do we plug in for here that would make that 0? +2. What number do I plug in there that would make that 0? -6. So +2 plugged in. So some of you might be going, but wait, if I plug 2 in here, I would get 8. So if you plug 2 in here, you get 2 minus 2, which is 0. Plug 2 in here, you get 8. 0 times 8 is 0. If I take -6, plug it in here, I get -8. If I plug -6 in here, I get 0. What's -8 times 0? 0. So the fundamental theorem of algebra said, hey, you can have 2 solutions because it's raised to the 2nd power. Your solutions to this problem are 2 and -6. If I had graphed this, it would cross the x-axis at +2, 0, and at -6, 0. Kind of gave you a whole bunch of places solutions exist like that. Can I move off this problem and do that second problem?
Yeah.
Okay. Move it up just a smidge. All right. So I have g at x. Means the same thing as f at x. Means the same thing as y. We're not really worried about that. But what I'm going to do is I'm going to take a look right here. I have 4x to the 3rd plus 8x squared plus or minus 12x. It appears we have a greatest common factor, which would be what? A 4 and a x. I can factor a 4 and an x out. If I factor a 4x out of 4x to the 3rd, I'm left with x squared. Plus comes down. If I factor a 4x out of 8x squared, I'm left with 2x, right? If I factor a 4x out of -12, I'm left with a -3. Here's our little brother. It comes down to the end. And I'm going to factor this. So just for sake of purpose, I'm just going to say it's x plus 3 and x minus 1. Trust me, it works.
But they're not the same.
That's just the answer.
That's the solution right now.
Oh.
So I factored out the greatest common factor. So if I factored out x squared plus 2x minus 3, our magic number is -3, so you're talking about 1 and 3 have to be multiplied together to get -3. -1 plus +3 is +2. So the whole thing works. So if I apply my fundamental theorem of algebra to this, I have 4x, x plus 3, x minus 1 equals 0. Okay? So remember, I need to figure out what values to start plugging in. So 4 times what number gives me a 0? 4 times what number gives me a 0? 4 times what number gives me a 0? 0. There's one solution. What number do I plug in here to make that binomial 0? -3. What number do I plug in right there to make that binomial 0?
+1.
What is it?
+1.
+1. So my solutions are 0, -3, and 1. If I plug those values in, it's going to give me one part of the problem being 0, being you're multiplying 3 terms together. If one of those terms is 0, your answer is 0. So if I were to have graphed this, it would cross at 0, 0. It would cross at -3, 0, and it would cross at 1, 0. We okay with that? So we're adding an equal sign. We're figuring out what values make our answer 0. That it? Ooh, done. Okay, so I just want you to think about this. Just want you to think about it for a sec. We already talked about this type of problem. That, and that are your solutions. So if you look back at our last problem, we have 0, -3, and 1. 0, -3, and 1. I mean,
Oh, and that's how you do it? You just plot the points,
that's
and then that's how you get the...
That's it. So this point right here would be -3, 0. This point right here is 0, 0. This point here is 1, 0.
So that means that's 3 solutions.
The solution is where it crosses the x-axis. The solution means if I plug it back in, my answer comes out to 0. Cool? That's it. That's all I got. Yeah, baby. All right, let's see what we got for homework or assignment. Somewhere in here. That could be. Yeah, that's it. So 63, 64. Oh, and one question that came up yesterday. We started changing letters on you, right? You can change all your letters to X if you want to. But like if you have X and Y in a problem, don't change them both to X. But like if your answer is like C squared plus 5C, you can make that X squared plus 5X. Right. Yeah, let's do page 63 and page 64. Ladies and gentlemen, what are we doing about this quiz? If you wanted a second look, you need to do what? Come in to see me. Can you come see me during a class? Absolutely. I'll have your test with me. Can you come see me in my office? I'll be in my office today through 8th period. So if I'm not in class, then you can find me in my office. Tomorrow, I will be not in class. I'll be in my office up until 6th period. And that includes if you have to make up the test as well, or the quiz as well, please. If you don't, I'm going to hand the test back on Monday, go over it. So don't be that person going, I think I was going to study real hard, but I decided not to, so I'm going to just take it next week sometime. So I'll make up a different version for you. And it won't be nice. Cool? Happy?